Good afternoon, everyone. I'm Benjamin Attal. I'm an AI solution consultant working at DDN. So thank you, Vultr, for inviting me. So the idea is to talk about a joint architecture we did with Vultr for powering an AI infrastructure from inference and training. So based on DDN data storage and Vultr IP. So the idea is to talk a bit about me, about DDN, right? And then explain why storage is important, why infrastructure is still important. We'll talk about a bit techniques. Okay, what is a RAG, for example? How do we implement it? And then we will demonstrate a full infrastructure based on Vultr IP and DDN product. So first, who is DDN? Who knows DDN? 1, 2, whoa, my goodness. So it's the most unknown company in the AI world, but a very, very powerful company, okay? We are supercharging 700,000 GPU in the world. So it's enormous, right? So for example, we're training XAI. Everything run on DDN, right? Mistral run on DDN, right? So many companies also use our product. So you see different verticals here. So energy, okay, mechanics, pharmaceutical, healthcare, public sector, everybody. So we began first 27 years ago. So it's an old company actually, right? In the HPC sector, for the HPC computer, high performance computing, right? And then in 2017, we adopted AI. So, and NVIDIA is our first customer. NVIDIA used DDN, right? That's why we are here. So every time you see, let's say, a big data center requiring some performance, because we are very good at performance, it's fueled with DDN products. For example, here, the NVIDIA data center, so EOS and Selene. You have a data center in South Korea, in Japan, in Cambridge, UK, in France here. Scalable runs DDN, right? So every time you need performance, a lot of IOPS, small latency, DDN is in the place, right? So Jensen is a friend of us, and we love NVIDIA, and it became, let's say, 8 years ago. NVIDIA was looking for storage for training their own models. And so they were requiring a lot of performance. And training a model is very specific. Let's say you have GPUs working, and you need to access the data, a small subset of data at the same time. So you need a parallel file system. And there are very few parallel file systems in the world. And DDN does have one called Lustre. Okay, our technology is incredible. Okay, and we helped NVIDIA train their own model. The second thing is when you train a model, sometimes you need to stop. Okay, you need to make a picture of the model, and then change the parameters and move forward in another direction or do a fork, for example. So it is called a checkpoint. A checkpoint is it's a massive write of data. You need to store all the bias, the weights of your neural network in a very short amount of time. So almost there are very few systems in the world that can do that, and we can do that, right? That's why. So let's talk about DDN. So we have two products actually, because the world of AI is divided in two. There is a world of training models. So I talk about that. Okay, it's more the product called Exascaler, Exasec, and the world of inference. Inference is using a model, running a model. So here you need to have a time to the first byte very small. Latency needs to be very small, right? So you need a lot of throughput and latency to have a very good quality of service. You don't want to wait. So you are prompting, you don't want to wait. You want to have your tokens popping up, right? So there are two different systems. So, but in every case, DDN is providing enterprise level service. Okay, so we need to provide security to our customer. For example, Vultr will buy one big DDN. They will slice in many customers and give resources to each and every customer. It's called multi-tenant. So we need to provide multi-tenant. But each of the tenants need to be isolated, encrypted, secured, right? So we do provide that. We do provide resiliency. There is no single point of failure, right? Okay. Performance. We are very, very good at performance. As I said, we have almost 800 people working in our labs on performance, doing benchmark. So it's a very technical company actually, right? So I won't go too deeper into the details, but when you talk DDN, you talk performance. Scalability is very important because most of the customers begin small, so you can begin with just one box, and then scale up. And the most problem they will face is when they are scaling, right? Scaling is a problem, right? So here, because we are following the reference architecture of NVIDIA, we are qualified for superpods, all right? So there is reference architecture. When you go to the NVIDIA page, there is a lot of reference architecture type. We are one of them, right? We did work on the network layer. We have a specific network layer for accessing the data. I mean, this is not a common layer. This is InfiniBand. This is ROSI. This is very, very small latency. It's very specific. Okay. Okay. So let's say you want to scale. You will add up boxes, 1, 2, 3 boxes, and when you add boxes, you double, you triple your performance. It's incredible, right? So and let's talk about the efficiency. So we worked on a form factor very compact. So let's say our box are 2 use or 4 use. That's very small, right? And inside you have a bunch of disks and the secret sauce of DDN, of course, okay? And we deliver a lot of performance with a minimum consumption of energy, because energy is very important. Let's say, as of today, energy is one of the highest costs of a data center for a customer. So let's say we worked on everything: performance, energy, space, okay? And at the end, you have something very, very performance in a very small format. This slide is just for you to understand the movement of data when you are, let's say, delivering a AI infrastructure. So let's say, and in both cases, even if you do inference or if you do training, there is a lot of things going on with the data. For example, the first thing you need to do is loading your model. You load your model. If you are agentics, you load many models. You don't want to wait. Okay, you need to have a very small latency for loading rapidly your model. Then you need to inject your data. Everything is about data. At the end, you need to work on your data. So let's say you have tons of documents. It may be videos, it may be a PowerPoint, it may be PDF. A lot of them, you need to work on those documents. You don't want to wait. You need to inject that very rapidly, and we provide a very slow latency. Then you will work on the documents themselves. It's called pre-processing. So we will take the value inside the document to make it ready for AI, right? So, and here you read, you write, you read, you write. It's very intensive. Once it's done, then you're ready for training. So you are moving your data to the trainer, right? The trainer will massively use your data. I talk about that, so doing readings, checkpointing, and it's massive. So there is a movement here, okay? And when it's done, you can load your model. So as you can see, first, infrastructure matters. Secondly, data matters, storage matters. So you need to have something very powerful and performance to back your infrastructure, right? So whatever the word is, training or inference. So I wanted to make a pause and talk about the new product we have called Infinia for doing inference. So it was a blank page 7 years ago, and we built everything, right, with NVIDIA, by the way. The idea is to create something with the same DNA as a model. And the model, first, what is the a model talks token. So, and we talk token. A model loads token in a KV store, and we have a KV store. Okay, it's very, very similar, the same technology. And on top of that, we created services for our customer. If they want to use S3, they can use S3. If they want to put, let's say, a container in CSI, they can do that. If they want to do POSIX, if they want to do SQL, they can use that, right? So those are services on top of that, right? If they want to use our classical framework to do training, I don't know, PyTorch, TensorFlow, whatever, we provide the library for doing that. If they want to use NVIDIA, I don't know, Nemo, NIMS, or whatever, we integrate with those frameworks, okay? So this is typically a new product. It's a brand new product. It is massively used by Grok, XAI in their infrastructure. Just a bit of marketing. I like that this one. So let's say we provide a S3 service, but it's let's say in terms of performance versus a bucket in Amazon in AWS, it's 100 times faster and performant. All right. Let's say it's nothing to see, nothing to do, right? I mean, if you have, let's say, a problem of loading tons of videos in a small amount of time, think of NVIDIA, Infinia. DDN is the way to go. So, don't worry. It's let's explain what is a RAG. So I will move a bit just for so everything is begins here. This is you prompting, like asking something to your preferred LLM, right? But you are a company, you want to provide the best answer to your user and agents, but you don't want to do any kind of training. Let's say the LLM is intelligent enough, but you want to give very specific data, your own data. Okay, what is your own data? Your PDF, your videos, right? Your text, everything. This is multimodal, right? So you need to do something called a RAG for doing that, right? First, you need to work on the data and transform that data to be AI compatible. So for that, we are doing an embedding with an embedder. So we read the data, we transform it and store it in a vector database. Okay, this is it's a bit complicated to understand, but this is a space of meaning, a space of meaning. Your data is a vector. Your vector has a meaning, right? And when your user is prompting, we will intercept the prompting, we will reformulate it, and we will embed it. Okay, and it has a meaning. Okay, it is a vector into your meaning space, and then we will compare your prompting with the data we have. If it's close enough, it's a good candidate, right? So we will take the candidate, and we will re-rank it, and we will get everything to the LLM. Then the LLM has a good prompt and a lot of good data, and we will fuse everything to give the best answer. Of course, at the end, you can have some hallucination, or you want to implement some kind of policy, so you implement a guardrails, right? For avoiding, let's say, non-political answers, right? Because this is a RAG. It is really simple to implement, actually. So, I wanted to talk about that because Vultr implemented the way for their customer in the cloud service to do AI training based on DDN and GPU from NVIDIA. Let's say inference with DDN and NVIDIA too, and BI, okay, in your service to avoid the problem of scalability, let's say latency and performance. So everything I will talk about is in production as of today. It's a joint infrastructure of Vultr and DDN. Do not worry, I will explain everything. Okay, so here everything is about data. Let's begin with the data. So here you have 4 different sources of data. Okay, so first we are talking about a healthcare company, right? Healthcare means secrecy, privacy, HIPAA. Okay, so we need to be careful with the data we will store. There are four sources of data spread over 2 cities, New York City and LA. Okay, and we will inject this data at 3 levels of service. So the 3 types of storage. One for doing training, you remember, checkpointing, okay? One for doing RAG, you remember the RAG, okay? And one for a classical portal, right? 3 levels of service, right? So here, Vultr deployed a portal for the customer using their classical service. So you have a virtual load balancer, you have a series of a Kubernetes cluster here, and data stored here. It can be S3 data, it can be a virtual managed database, right? Backing the data for the customer, right? So you have two types of user, clinicians and patients. 2 worlds, right? 2 different worlds. So, and on top of that, you have an AI pipeline. I will explain it to you. So here, you have GPUs for the training. You remember, the training, it's a massive run of a neural network. And you have 2 types of agents. It's an agentic. Wow, it's a level of, it's not a simple chatbot, you know? It's an agent infrastructure. One for the patient, more informational, and one for the clinicians, more technical, right? They created a specific agent, so it's a specific AI for both worlds, right? So they are training it, and when they are ready, they're storing it in the registry, okay? And they decided to implement a RAG, but it's a far more elegant way of doing that. So the RAG, if you remember, my RAG was more static. Here, they implemented a stream of data. So every time you have a storage, a new object popping up here, there was a Kafka message saying, please take that data and transform it and put it in my vector database here or here, right? It's far more dynamical, scalable, and you can log everything, and log is really important in the healthcare world, right? So you have 2 worlds here, a classical world and an AI pipeline. How do you make the first one talk to the other? Here, okay? There is a serverless API. So when the clinician or the patient do a prompt, we take that prompt and send it to my AI. It will work. It will do this RAG. It gives the answer and the answer. Okay. So it is honestly it is a very beautiful infrastructure. It's a level. It's not a simple one, right? It has been very well thought, using all the characteristics of DDN storage, very performant storage, by the way, and the mindset of Vultr for delivering a beautiful architecture. So it was my last slide. If you have any question.